Okay, so we're looking at solving linear equations where both expressions that make up the equation contain a variable, the same variable. So what that would look like, remember that an equation is just built up of two expressions. Expression number one, expression number two, and relate somehow their values being equal, possibly. So usually we would look at something like this: 3x plus 2 equals 13, something like that, where we could find the value. In this case, it'd be a rational value for the unknown. What's different now is that we'll start including variables on both sides, or in both expressions of the equation. So we're going to go through the process for how to solve when you've got that. So again, because we're solving, the goal is to find a value for the unknown, the variable, that will make the statement true, in this case, statements of equality. So in this case, you'll notice that we do not have to do any kind of distribution. There's no grouping. This side is simplified and the other side is simplified, so there is no collecting of like terms. But we do want to get the variable in just one expression. We want to get it on one side or in one of the expressions. And what we're going to do is we're going to make one of these variable terms a zero. We're going to make creative zeros or make it a zero using either the addition or subtraction property of equality. So in this case, we could subtract 4x from both sides, and that would make this go away. Or we could subtract 7x from both sides to make this go away, to make this a zero. We can do either one, but usually we pick the action that's going to give us a positive sum or difference. We want a positive answer, because that might reduce our work later on. So that's what we're going to go for. So you'll notice that I could keep, even though this goes away, and I'll be left with 6, this becomes a 0, and 0 plus 6 is 6. That's what I mean by go away. Over here, 4 minus 7 would leave me with negative 3x minus 2. And we can still work with that negative 3 coefficient, but since we have the option to get a positive coefficient, that's what we're going to do. Ideally, you try to get the variable on one side and positive. Yes, you can still solve it correctly with a negative coefficient, but it might mean more work. So it's better to get in the habit of solving it. So in this case, when I subtract 4x from both sides, this becomes a 0. And 7 minus 4 is positive 3x, and then plus 6. And that's what we want to get, that positive 3x right there, positive. So that was the work. And then once we finish simplifying, 0 minus 2 is negative 2. And that right there is the process of making our variable, getting it to one side. And that's really the only new thing for us in my class. The next two steps are review of what's come before. We would make the constant a 0 on the side with the variable, so we subtract 6, losing 2, and we lose 6 more, we've lost a total of 8. And then this is a 0, and 3x plus 0 is 3x. So there we've made our coefficient, or excuse me, our constant into a 1 using the subtraction property of equality. And then the last step is we'll make the coefficient a 1 by dividing by the coefficient, in this case using the division property of equality. And so here we go, 1x, 3 over 3 makes 1, and 1 times x is x. And negative 8 divided by 3 is negative 8 thirds. As an improper, you can make it a mixed number, as that's negative 2 and 2 thirds. As a decimal, it would be negative 2.6 with the 6 repeating. Any of these three answers, they're all the same, just the different forms. and there would be the last step, just making that coefficient a 1. So let's look at just 2 more examples. In this case, we don't have to distribute. There's no groupings, no parentheses or brackets. This side is simplified, 1 variable, 1 constant. This side is simplified, 1 variable, 1 constant, so there's no collecting of like terms. We do have a variable on both sides, so we're going to do what we need to do to get that onto one side and positive. If I add 3x, this does become a 0, but negative 9 plus 3x will still be negative 6x. So I'm actually going to make the negative 9 into a 0. I'm going to add 9x to both sides. And the reason why I want the negative 9x to go away, that becomes a 0. And 0 minus 4 is negative 4. And the reason I added 9x is because negative 3 plus 9 is positive 6. And that's going to make my work a little bit easier and possibly cut out a step or two later on by having a positive answer. So that's the step of getting. We're just making a creative 0 out of one of the variable terms. And then after this, we'll make our constant a 0. And everything after this is just review. This first step is really the only new step we're practicing here. Lose 4 and lose another 11, we've lost 15. And that's the step of making the constant into a 0. And then we'll make the coefficient into 1 by dividing by 6 and dividing by 6. And that gives us negative 15 sixths for our unknown value. It can be reduced to negative 5 halves. Or it could be negative 2.5. Or it could be negative 2 5/10, the decimal version of that. So any of those would work. And let's look at just one more example. In this case, we do not need to distribute. There's no groupings. We have both expressions are simplified. Let's get the variable on one side. So plus 4x to this side and plus 4x to this side. The reason I'm adding 4 is because 10 plus 4 is positive. If I took away 10, then I'd have a negative 14x on this side. And it's better to have a positive coefficient. So 10 and 4 gives me 14x plus 2 equals. And here's where we might make a mistake. We think there's nothing there, and so we don't want to finish our equation. But remember that 0 is a number. And in this case, negative 4 plus 4 is 0. So don't get scared if you get zeros. Zeros are numbers. They have their place in equations. So we got our variable on one side right there. Now we'll make our constant a 0 by subtracting 2. So we have 14x plus nothing is 14x, and 0 minus 2 is negative 2. So we got our constant into a 0, and then we will make our coefficient into a 1 using the division property of equality. 14 over 14 is 1, and 1 times x is x. And we're left with negative 2 divided by 14 is negative 2 14ths, or we can simplify to negative 1/7. You could give the decimal value, but it goes on and repeats, so its fractions are more exact and more compact. But there we go. There's 3 examples solving equations where you get variables showing up on both sides of the equal sign, both expressions of the equation. All right.